Imagine you're in the middle of the ocean, surrounded by waves so big that they could swallow a whole skyscraper. These are monster waves, unpredictable, unforgiving. The sea is dangerous by its very nature, but it is the duty of the Navy to sail its treacherous waters, whatever the weather. So how do Navy ships withstand mighty storms and all that nature can throw at them? Stay tuned, and you'll be surprised to learn that it's not just the size of the ship that counts, but also hard-earned experience and some pretty smart tech. Join us as we uncover the Navy's biggest game changers, from AI-driven stability to cutting-edge sea defenses. By the end of the video, you will know everything about how they stay afloat despite the raging chaos of the ocean. Life on the open ocean is unpredictable, perilous, and often brutal. For US Navy sailors who spend months on long missions, the risks are magnified. The weather at sea is a major challenge. Strong winds, often exceeding 60 knots or around 70 miles per hour, create powerful currents and massive waves. Some storms can produce waves as tall as 100 feet, like mountains towering over the ocean. Imagine the sheer force of that water slamming into a ship. It's enough to affect its stability, making it hard to steer and increasing the risk of capsizing. And it's not just the ship's structure at stake. The lives of thousands of crew members depend on these vessels staying steady. An unstable ship can cause heavy equipment and machinery to shift dangerously, leading to injuries or even catastrophic damage to the vessel itself. Considering that on any given day, about 50,000 US Navy sailors are deployed across nearly 100 ships worldwide, the importance of safety cannot be overstated. So what is at stake as the Navy tries to outmatch Mother Nature? Think of it this way. Have you ever tried balancing a pencil on your fingertip? Now, imagine doing that while riding a roller coaster. That's similar to what happens on a Navy ship during a storm. The balance, stability, and strength of these vessels are a marvel of engineering and physics, designed to keep them upright and functional, even in the most violent conditions. So what makes these ships so resilient? Let's break this down in the simplest way possible. Ships float because they're designed to be less dense than water. Water pushes up, and gravity pulls down. If the upward force is stronger, the ship stays afloat. Pretty straightforward, right? Now, to stop a ship from tipping over, the center of gravity has to be low. That's why all the heavy stuff, like machinery, fuel, and equipment, is placed as close to the bottom of the ship as possible. It's not random. Engineers carefully plan this to make sure everything stays balanced. Now let's talk about the shape of the ship itself. The hull, which is the bottom part of the ship, plays a huge role. Most Navy ships have a large U-shaped hull that gives them stability, helping them resist tilting and rolling in jerky seas. But when it comes to the big guys, like aircraft carriers, they use a V-shaped hull. This shape cuts through waves like a knife, making them less affected by the height of the waves compared to smaller ships, which can get tossed around like toys. Aircraft carriers also use ballast systems to keep their balance. Just like holding a scale in your hand and adjusting it to make both sides even, that's what these ballast systems do. The crew can raise or lower the ship's center of gravity by filling or emptying tanks with water. This helps the ship stay stable no matter how rough the sea gets. Now, let's talk about the tech these ships use. First up is the fin stabilizer. These are like the wings on an airplane. These fins are attached to the ships and adjust constantly to counteract the rolling and pitching caused by waves. For Navy ships, especially those on long missions or conducting precision strikes, these are absolutely critical. Without them, trying to aim or fire weapons accurately in rough seas would be next to impossible. These fins keep the ship steady, even when the sea is doing its best to throw it off balance. Another amazing piece of tech is the gyroscopic stabilizer. This works kind of like a spinning bicycle wheel. It keeps things upright. Inside the stabilizer, there's a flywheel spinning at an insanely high speed, around 10,700 revolutions per minute. This spinning creates angular momentum, which generates a stabilizing force, pushing and pulling the ship to keep it level. What's even cooler is that it's controlled by computers, which adjust the system in real time to match the sea's movements. It's like having a high-tech babysitter for the ship, keeping it balanced in all kinds of crazy conditions. All of these things together, low center of gravity, carefully designed hulls, ballast systems, cutting-edge fin, and gyroscopic stabilizers all work together to make these Navy supercarriers nearly unstoppable. They're like floating fortresses, built to handle whatever the ocean throws their way. But no matter how advanced the technology, the ocean always has the last word. It's a constant battle between human innovation and nature's raw power. So far, these incredible ships are holding their ground. Not one has been lost to a storm. To keep these massive warships running like a well-oiled machine, the crew works tirelessly behind the scenes. These ships need to be operational 24/7, no matter what. That means maintenance isn't just important, it's absolutely critical. The Navy can't afford to wait for something to break. That's why they focus on two main types of upkeep: preventative maintenance and corrective maintenance. Preventative maintenance is staying ahead of problems. It's like giving your car a regular checkup before anything goes wrong. The crew makes sure every part of the ship, from tiny bolts to massive engines, is in perfect shape. They perform tasks like lubricating machinery, checking fluid levels, running tests, and even listening for strange vibrations, anything that could cause trouble. This attention to detail ensures the ship stays ready for action at all times. On the other side, corrective maintenance comes in when something breaks or malfunctions. If a system fails or gets damaged, the crew jumps into action, repairing and restoring it as quickly as possible. After all, a breakdown at sea is not only expensive, but could also be very dangerous. Imagine trying to fix critical equipment while waves are crashing all around you. That's not a situation anyone wants. To take things a step further, these ships also go through dry docking and overhaul maintenance. Dry docking is the ship taken out of the water so the crew can inspect and repair parts that are normally submerged, like the hull and propellers. Overhaul maintenance, on the other hand, involves taking apart key systems, checking every detail, fixing any issue, and putting everything back together. It's a massive job, but it's necessary to keep these ships in top condition. So why all this effort? Because at sea, there's no room for surprises. A faulty engine, a leaky hull, or a broken system can quickly turn a mission into a life or death situation. Dry docking and overhaul maintenance ensure that when the ship heads into unpredictable waters, it's in peak condition, ready to take on whatever challenges the ocean throws its way. Avoiding trouble is just as important as fixing it. The Navy doesn't just sail blindly into dangerous waters, they plan every move carefully. Before setting sail, they analyze weather patterns and map out the safest routes, avoiding rough seas and deadly typhoons whenever possible. But even with the best planning, the ocean is unpredictable. That's where cutting-edge weather forecasting comes in. With this information, the ship's navigation system can calculate the best routes to avoid rough seas, high waves, or dangerous currents. It's not just about dodging storms, though. Onboard systems also help adjust the ship's speed and heading to minimize the impact of rough waters. So with advanced technology and skilled meteorologists, the Navy stays one step ahead of nature. Furthermore, high above the ships, satellite systems constantly scan the Earth's atmosphere, tracking clouds, wind speeds, water temperatures, and even dust storms. These satellites help predict storms long before they become a real threat, allowing ships to adjust course and steer clear of danger. But satellites aren't the only tools at work. Spread across the world's ocean are over 1,000 water buoys, floating sensors that silently measure wind strength, wave height, air pressure, and sea temperature. These buoys act as the ocean's pulse, detecting hurricanes as they form, pinpointing their exact location, and even predicting how powerful they'll become. Raw data alone isn't enough, though. The Navy uses sophisticated environmental models, like the Joint Typhoon Warning Center models and Wave Watch 3, to turn this information into detailed forecasts. These models predict wind patterns, wave movements, and storm paths, helping the Navy plot the safest course, even through unpredictable waters. The ocean can rage, waves can rise, and storms can strike. But with cutting-edge technology and expert planning, the Navy's steel giants continue to stand strong, ready to face whatever the sea throws their way. With new technology shaping the future of warships, naval engineering is evolving rapidly. The US Navy is already exploring cutting-edge advancements that could make ships lighter, smarter, and more resilient than ever. One major change is the use of lightweight composite materials in shipbuilding. These materials reduce overall weight while maintaining strength, making ships more fuel efficient and resistant to corrosion. A lighter ship also means better stability, reducing the risk of capsizing in rough waves. Another futuristic innovation is adaptive hull surfaces that can change shape based on sea conditions and ship speed. This smart technology would help ships stay stable in rough waters while also improving fuel efficiency. In simple terms, it means smoother sailing and lower energy costs, a win-win for both safety and sustainability. Now here's something you don't hear about every day: virtual reality training for Navy crews. Mistakes at sea can escalate quickly, so training is everything. With VR, sailors can experience realistic storm conditions, practice emergency responses, and sharpen their decision-making skills in high-pressure situations, all without leaving the safety of the training room. And then there's artificial intelligence stepping into the game. Future US Navy ships could be equipped with AI-powered stability systems that constantly analyze sensor data and make real-time adjustments to keep the vessel steady. These self-learning systems could predict and counteract rough conditions before they become a problem, potentially preventing capsizing scenarios altogether. But let's not forget the most important part of all: the people. At the end of the day, it all comes down to the people behind the machines. The US Navy trains its sailors to handle everything from rough seas to emergency situations. Their expertise, combined with the ship's cutting-edge technology, makes them a force to be reckoned with. But the Navy's strength isn't just about surviving storms, it's about staying mission ready at all times. Behind the scenes, a dedicated team of engineers and technicians work non-stop to keep the ship in top condition. They repair, upgrade, and maintain every inch of it, making sure that every bolt is tightened and every circuit is tested. Often when a machine fails, there's a human being behind it to shore it up. These sailors' efforts ensure that when it's time for action, the aircraft carriers aren't just massive floating fortresses, they're well-oiled machines ready for anything. The future of naval warfare is looking more advanced than ever, and these innovations could change how ships operate in the years to come. But let's hear from those with real experience. Any current or former sailors out that have been through a storm at sea? How was it? Drop your stories in the comments, and thanks for watching. See you in the next one.